Okay, here's some questions. Here's the 4-5 assignment in Algebra 2. The key to being able to do these is knowing your properties right here. You're going to have to be able to take a log of a product, turn it into the sum of the logs. That's this. The log of a quotient, turn it into the difference of logs. And the log of a to a b power, pull the exponent out front. So we're going to use those on this. Whenever I write a ln means log natural or natural log. When you write a fractional exponent, you always write it as power over root. The power is 3 and the root is 4. That enables me at this point to take the rule that says log of a to the b power and pull the b out front. So I should be able to pull this out front and call it 3/4 natural log of x. And that is my answer. 27 is a log base 2 of the square root of x. Remember, it's power over the root, which is 2. In other words, a square root can be written as a 1/2 power. Again, I'm going to use this property that allows me to pull the exponent out front. So I'm going to pull this 1/2 and put it in front, giving me 1/2 log base 2 of x. In 25, you have a different property that you're going to have to use. The reason I say that is, please note these are multiplied. So you might have to use log of a times b equaling log a plus log b. So this could be written as the log, I got to keep natural log, of x squared plus natural log of y to the 1/3. The only thing left to do is to use the property that we used last time, which basically just says to pull the exponent in front of the logarithm. So I'm going to take this exponent and put it in front of the logarithm. So my final answer is going to be 2ln x, pulling this exponent out front, 1/3 ln y. Usually the instruction on these are to expand. You want to expand it out. There's also a group at the end that asks you to condense, go the other direction. Okay, some of the earlier problems give us log of 4 and give us log of 12. So, let's start with 11. Log of 144. Can I write 144 using 4s or 12s? I don't know why I wrote base 12. This is log of 12. How can I get 144? Well, 144 might be 12 squared, right? And we use that same property now to pull the exponent out front. So that gives me a 2 log 12. And if you look at the very top of the page, they tell you that log of 12 is approximately this. And when I multiply it by 2, I get 2 point something. So hopefully it's 2.158. Now we want to do the same thing with 1/4. And I want to use either the 4 or a 12. Well, 1/4 could be called 4 raised to the negative 1. Again, pulling your exponent out front using this property right here. I pull the exponent out front. And I now know on top that the log of 4 is 0.602. So that makes my answer negative 0.602. Okay, the first group of problems we did was expand. Then this group is going to be entitled condense. Put them together. Is there a rule that says log A minus log B would equal the log of A over B, I think? So could this be written log of 7 over 10? I'd keep the same base. So you want to write it as a single logarithm. You'll notice there's only one logarithm in my answer now. In 39, there's a rule that says log of A to the B, allowing you to pull the B out front. Could I also take the B out front and put it up top? Could I put this 2 up as an exponent? So I have natural log of 40 plus the natural log of 1/2 raised to the second plus ln of x. Well, what is 1/2 to the second? 1 squared and 2 squared, right? Is there a rule for multiplication? Log of A times B is log A plus log B, right? So could these two get put together and call it natural log of 40 times 1/4? So that becomes the natural log of 10. And again, if they're added, it becomes multiplication. So the answer is the natural log of 10x. You've written it with a single logarithm. So just to recap, I took the x, what's out front, put it up as an exponent. Then I simplified it. When you're multiplying, that's this property here, the adding becomes a multiplication. 40 times 1/4 is 10. Again, the addition here becomes multiplication, so it's 10 times x. Again, these take some practice before you get comfortable with them. 41 is similar. Can I put the 6 up as an exponent and the 4 up as an exponent? So that would be natural log of 2 to the 6 minus natural log of y to the 4th. 2 to the 5th is 32, so 2 to the 6th would be 64. How about subtraction? Do you know which one subtraction becomes? Division. So it's natural log of 64 divided by y to the 4th. What property was used was log of A over B equaled log A minus log B. I don't know if you see it. I'm just working backwards. I'm given the part with the minus, and I need to write it this way. In 45 and 47 and so forth, these are change of base. I usually, if I need to do a change of base, I would do the natural log of the argument divided by the natural log of the base and get a value. Same thing here. Natural log of the argument divided by natural log of the base. Same thing, natural log of the argument divided by natural log of the base. Now I'd like you to think with me a minute here, please. 4 to what power is 7? 4 to the 1 is 4. That's less than 7. What's 4 to the 2? 16. That's bigger than 7. So it's between 1 and 2. It's going to be 1 point something. How about number 47, guys? Please look. 3 to what power is 15? 3 to the 1 is 3. What's 3 to the 2? 9. That's still less than 15, but what's 3 to the 3? 27. So this is between 2 and 3. I know this is going to be 2 point something, right? 3 to what power is 6? Well, 3 to the 2 is too big, so it's probably 1 point something. Anyway, when you punch these in your calculator, you're going to get, so these should be the values if you punch them into your calculator for those. That's a change of base.